Man, this is a big problem. It's a big mess. So this must be a little problem. Just a little mess. Similarity. Same thing, different size. Alright, welcome back. Today's lesson we're going to talk about similarity. And we're going to use a couple of theorems, kind of like what we've done before, to prove things about triangles this time. Okay, and so our objectives are to prove certain triangles are similar by using angle, angle, side, 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 and side, angle, side. A little bit different than what we've used before, so pay attention to those. And we're going to also use triangle similarity to solve problems. Okay, so let's get right into it. Angle, angle, similarity. It says if two angles of one triangle congruent to two angles of another triangle, then the triangles are similar. Okay, so here we have ABC and DEF. What we can say about ABC and DEF is that they have two angles that are congruent. And because angle A is congruent to angle D, and angle B is congruent to angle E, the conclusion that we can make is that triangle ABC is similar to triangle DEF. Okay? And so what we're saying here is that all you need is two angles. You have two angles, you can prove that the triangles are congruent. Okay? Let's look at example 1 that goes along with that. Explain why the triangles are similar and then write a similarity statement. Notice, this is another one of those situations. If we have parallel lines shown, we're probably going to use that. And so what I'm going to do is I'm going to list the things that I know. Because these lines are parallel, I can say that angle T is congruent to angle S by the alternate interior angles theorem. Okay, and so I'm going to go ahead and mark that. And if I notice, I can also say that angle P is congruent to angle R. Same reason, alternate interior angles theorem. Okay? I can mark those as well. Notice, I've proved two angles now. I could prove the third angle, but I don't really need to because I have a theorem that I can say by the angle-angle similarity theorem. I have two angles that are congruent. So by the angle-angle similarity theorem, triangle TPQ is similar to triangle, now let's be careful, TPQ goes from 1 to 2 to the blank one, so this is triangle SRQ. So I can say that they're similar using the triangle similarity theorem. Important pieces that I used right here, alternate interior angles theorem. Remember that one because you're going to use it a lot in the coming examples. Okay? So, using that example as a guide, go ahead and try this one on your own. Bring that one to class. Okay? Shouldn't take you too long. I'll give you a hint. You're probably going to use the third angles theorem. Okay? We're going to move on to the side-side-side similarity theorem. Okay? The side-side-side similarity theorem says if the sides of one triangle are proportional to three sides of a corresponding to the three corresponding sides of another triangle, then the triangles are similar. So what I'm going to say is AB over DE is equal to BC over EF is equal to CA over FD. This is what I know. And so what I can conclude is that triangle ABC is similar to triangle DEF. So if I have just the three sides, notice, before we needed all 6 pieces, 3 congruent angles, 3 proportional sides. These theorems are designed so that we don't have to prove everything. If we can prove the 2 angles, we can do it. If we can prove the 3 sides, we can prove that they're similar. Okay? So that's the first part. The other thing is this. If I know that I have a side, AB over DE, and it's proportional to another side. And the side between and the angle between them is congruent. So if I have a side, an angle, and a side, so AB is proportional to DE, BC is proportional to EF, and the angle between them, the included angle, is congruent, then my conclusion is that triangle ABC is similar to triangle DEF. Once again, three pieces of information: the side, the angle, and the side. We're talking about similarity, so it's important to remember that this is not about congruence. It's about proportional sides and congruent angles. Okay? Let's use this info for example 2. Here's two examples here that I'm going to do, and then you can try one. Okay? Verify that the triangles are similar. So triangle PQR and PRS. So let's see what we know. I'm going to test this first. PQ over, and we want to compare PQ to PR. So PQ over PR is equal to 4 over 6, which is 2/3. And I'm going to also compare QR to, and that's the second two letters, so RS is equal to 4 over 6. So at this point, I have two sides that are proportional. Now, I'm going to also compare PR to PS, because that's what this says. PR and PS go together. So that's going to be 6 over 9, which is 2/3. What I've shown so far is that all the sides are proportional. So 3 sides proportional. And because I was given 1, 2, 3, 1, 2, 3 sides of each, I decided to try to test the sides. Well, if 3 sides are proportional, I can say by side, 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 similarity theorem, triangle PQR is similar to triangle PRS. That's how this works, guys. Okay, so we use the theorems and the information that's given to try to prove this. Okay, let's try another one. JKL and JMN. So this time they're inside of one another. Well, what I'm given is 1, 2 sides of this one, and 1, 2 sides of this one. So let's take a peek here. This is going to be a common similarity problem. So let me compare JK to JM. Well, JK is 2. JM is a little trickier because it's actually 4 plus 2, which is 6. So that's 1/3. I'm also going to compare this side over here. So JL, and it's first and last, so I'm going to compare that to JN. JL is 3, and JN is 9, because it's 3 plus 6, which is 9. Well, that's also 1/3. Here's the beauty of this. We have two sides. We don't have the third side, but notice what they share. I have a side, angle, side, which involves two sides in the angle. I need the included angle. Well, conveniently, between JK and JL, this angle here. And between JM and JN is also the same angle. So because angle J is congruent to angle J, reflexive property, I have by side, angle, side, similarity. And I can write that triangle JKL, and I'll just scroll up here, is similar to triangle JMN. Okay, so I'm using the information that I'm given. I'm not given the third side, so I can't use it. So I decided to use side, and then I saw that the angle between it. They stack these triangles on top of one another for a reason, guys. Use the information that you're given. Okay? I'm going to scroll down. But you have two examples now, and you can try to find out which one this is. I'll give you a hint. The fact that these are smashed together end to end might give you a key about these two angles. Okay? So try this one, bring it to class. Okay?